All right, folks. Question number 15. Sorry about the voice. Um, Runner starts with some unknown speed. That means we don't know V naught. And accelerates at 0.64. At 1.5, the speed is 4.15. And we're looking for V naught. So I love the physics Sudoku. It took me a while to figure this out, but you can see that we have, we have the yellow, we care about something in the velocity row. So that's a hint that let's start with the velocity function. And again, all of those formulas can be used to solve for anything inside the formula. There's just a hint of what information you have. So you know the final speed, meaning final being at this particular time, you know that he has a speed of 4.15. V naught is what we're looking for, so we're going to leave that as a variable. He is speeding up, so A is positive 0.64, and T is 1.5. Okay, so then you're going to multiply these two numbers, which will turn into 0.96. Then you're going to subtract that from both sides. And you get 3.19 equals V naught. Okay, check your work. That makes sense because the velocity and the acceleration are the same sign, so he was speeding up, and so he's going faster. Okay, this is 19 across 2 pages, so I'll clean that up before I Xerox. In preparation for dunking a ball, so they're trying to tell you a story. Basketball player starts from a rest and sprints to a speed of 6.0 in 1.5 seconds. Calculate the distance he traveled. Okay, you can always assume like the distance he traveled is the difference between x and x naught. So let's just make x naught 0, and then whatever we find is the distance he traveled. Okay, so since we care about the output, you might be tempted to start with the position function, but then you would realize you don't know x and you don't know a. So not a crisis. Just try another formula. But the big fat hint is we don't know a. This box is empty. So that means we're going to use don't know, don't care about a. Okay, there's other ways to do this, and I'll do it both ways, and you can just fast forward to the other way if you want. But the don't know, don't care about a is the fire drill formula. What I have is 2 different speeds. So the distance I traveled, got to include any head starts that I have, plus my average speed in that time interval times time. Okay, so did not have a head start, and he went from 0 to 6 at a uniform rate for 1.5 seconds. So 6 over 2 is 3 meters per second times 1.5 seconds, and he went 4.5 meters. Okay, that is the one-stop shopping way to do it, knowing that this box is empty. So you can move ahead to the next question if you don't want to see an alternate way to do it. Okay, so again, if you tried to use the position function, because that's what you're looking for, right? So that's really tempting. You would find out that that's fine. That's 0. That's 0. So be careful. You know, that's the final speed. Plus a 1.5 squared over 2, and you don't have enough information. You don't know a, so you don't have a full function to finish the calculation. So the hint using the physics Sudoku is that this row is complete, right? We've got V final and V initial. So that's a hint. These hints don't always work, but that's a hint that let's use the velocity function. So my output of the speed velocity function is 6. I started at rest. And when I'm looking for my acceleration times 1.5. So my divide both sides by 1.5. And that is a 4. Okay, so we didn't really care what that was. That's why we call it don't know, don't care about acceleration. But it's useful information, and now you can complete this function. Now we can say the distance traveled is 0 plus 4 times 1.5 squared over 2. And if you run through that math, you get 4.5 meters. Okay. Fan car begins at x equals 0. It's given a push opposite the direction of the fan is pushing. So the fan cart's trying, let's just say the fan cart's trying to make it go this way, and you push it this way with a speed of 5. And so that fan's going to slow it down. It's going to have a turnaround point and then come back the other way. So the fan is just a different way of, it's the exact same problem as sending a cart up the incline and then back down the incline, except gravity's pulling this opposite the direction of motion, and here fan is pushing the cart opposite the direction of motion. Okay, initial velocity of 5 and some unknown negative acceleration. The cart reaches a max position of 12.5. Okay, so the hard part of word problems is getting the right signs, positive or negative, and catching the hidden clues. So remember what happened with the incline lab. Max position means V equals 0. Okay, so that is hidden information that you have to translate from words to numbers. And then it says calculate the fan cart's acceleration. All right, so in this case, we don't care what time that happened. We just want to know, hey, how far did it go before it came back? Could not care less about the time. So that means we're going to use don't know, don't care about time. And V final is 0. That's going to clean things up a little bit. V naught squared is 5 squared plus 2a. We're looking for a, and x minus x naught is 12.5 minus 0. So we have 0 equals 25 plus, actually I think that's 25a. Subtract 25 from both sides. So we get minus 25 equals 0 plus 25a. And then divide both sides by 25. And negative 25 over 25 means a is negative 1. Okay, nice clean number there. Okay, and then if you wanted to find the time that can happen, you could, but they didn't ask for that. Okay, so this one, they're trying to be, realistic and convince. So some people have to take physics or in nursing school, so they're trying to teach you the physics of the body. So I kept this in there. V naught is 26 centimeters per second. We're not going to need to convert. We're just going to know that what we're dealing, all of our values are in centimeters. Okay. From rest, sorry. So V naught is 0, V final is 26. And let's just decide it started at 0 and it went 2 centimeters. And we don't know the time. And we don't know the acceleration. So that's pretty tricky, right? Because we don't know either of these. So determine its acceleration in centimeters per second squared. Okay. So we're not going to use don't know, don't care about acceleration. Actually, we could. Except no, because we care about acceleration. Oops. So care about the acceleration. We have this row and this row complete. But the velocity function is always easier than the position function. So let's start there. Because there's just fewer terms and there's no t squared. Oops, see. Okay, so V final is 26. V naught is 0. We don't know A. And we don't know T. So that is a problem. What we could do is, so again, sometimes you just gotta experiment and try things out. Let's okay, so even I don't always get it right, but that's okay. It's like, okay, I'm stuck. Let's try something else. So we do care about acceleration. So we're not going to use the fire drill formula. But we don't care about time, right? We don't care about time right now. We don't know it, but we don't care about it. But we do care about this. So let's use, I'm so sorry. Here's the equation without time. So that's the only thing we don't care about. So this equation is everything else. Okay, so v squared is 26. It started at rest. We really care about a, and x final minus x initial is 2. So you get 676 equals a 4a, and then divide both sides by 4. And they're just trying to impress, I mean, real numbers, I'm assuming. So your heart is pumping, it's making the blood go from 0 to 2 centimeters per second, 26 centimeters per second. With this acceleration, which is 1.69 meters per second squared, but that's pretty impressive for something so small, right? All right, I'll stop geeking out because there is a part B. How much time did that take? So now that we know A, you have all kinds of options. You could use whatever you, well, not whatever you wanted. You couldn't use don't care about time. So again, let's use the velocity function because that's always easier than the position function. So 26 equals 0 plus 1.69 t. Divide both sides by 1.69. And you get a time of 0.154 seconds. Right? Really fast. Okay, so that's not the acceleration, that is the time. All right, people, hang in there. We got one more question. So we have a jetliner with a speed of 69, and it has 750 meters of runway. And it's going to go from big speed to small speed, and we care about the acceleration. But we really don't care how much time this took. We really want the acceleration. So V final is 6.1. V initial is 69 square, or 69. We care about A, and we have 750 meters of runway. Okay. So you get 37.21 equals 4761 plus 1500 A. And then subtract this. And you get minus 4724, because this is so much bigger. The numbers I didn't line them up well, but this is 4,000 something minus 37. Okay, equals 1500 A, and then divide both sides by 1500, and you get a negative acceleration because it is slowing down going forward of 3, which is nice and gentle, right? Like that's not, you don't know yet, but acceleration due to gravity is 9.8. So that's a reasonable acceleration. That's not going to like jar you in your seat. Okay, where are we? Not on an airplane. We're at the end of the problem set. All right, good job. See you in class.